So these problems are different because we're given a point. And this point belongs to f of x, just like before. So this is saying that we have f of 0 is equal to 6. It's giving us our coordinates for f, and where we use that is to get rid of that constant. So if we know f prime of x is that function, then we can say f of x is equal to, and then we do our little antiderivative. So we put a 3 and a 3, we bring down the 3, and then we check it. So it cancels, we get 3x squared, perfect. Moving on to the next one. We would get x to the 2, put it under 2, put a 6, and then the 2 would cancel, x to the 1, perfect. Minus 2x, and then plus c. So if we simplify this, we get f of x equals x cubed plus 3x squared minus 2x plus c. So now what we can do is take that function, that point that's given for this function, and plug it in. So we know that it equals 6. So if I plug 0 in for all of the variables, you notice what I'm left with is constants and c. So now there are no more variables. So this is 0 plus c, and so now you can see, no pun intended, that c is equal to 6. So we can now rewrite our function in the final answer form, which is f of x equals x cubed plus 3x squared minus 2x plus 6. And there you have it. And now we should still check this. So if I take the derivative, I get 3x squared, 6x, minus 2, and then we get 6. And if I were to plug in 0, all of these would cancel, leaving me with 6. So it checks perfectly. All right, let's try a trig function. So what we have here is our f prime of x, and like before, I stated that you want to distribute these to make them a lot nicer. So we get secant squared x plus secant x tangent x. So now our original function f of x would equal, what was the derivative that gave us secant squared? That was tangent. And the derivative that gave us secant x tangent x was secant x, and then we put plus c. So now we can get rid of that c by doing the same thing. We're going to plug in pi over 4, and that will equal negative 1. So tangent of pi over 4 plus secant of pi over 4. Come on, green. Plus c. There we go. See, it also helps by putting it in green, you know what you're looking for. So negative 1 equals tangent of pi over 4 is 1, secant of pi over 4 is rad 2, plus c is what we're solving for. So we need to subtract the 1 off to the other side, and the rad 2 as well. So we end up with c equals, that would be negative 2 minus rad 2. Now we just have to put it back together in its final form. So f of x is equal to tangent x plus secant x minus 2 minus rad 2. And then we just check by taking the derivative. So tangent x would be secant squared, perfect. Secant x would be secant tangent, and then the derivative of this constant would end up being 0. And if we unfactor it, we get this. If I plug in pi over 4, I should get negative 1. So let's check that. F of pi over 4 equals tangent of pi over 4 plus secant of pi over 4 minus 2 minus rad 2. And then this should end up being negative 1. So that's 1 plus rad 2 minus 2 minus rad 2. Cancel, cancel. That gives me negative 1. Check. If you're a little incompetent about your trig work, you can also just plug it in a calculator and see that it is negative 1. Make sure the mode is in radians. But it checks. Always check your work. There you have it.